Good day, sir. Good day, classmate. Good day to the watchers. So, I am Isabel Emma Liorca, a third year student from the Bachelor of Secondary Education, major in Mathematics from the University of Southeastern Philippines, Tagum Mabini campus, specifically in Tagum unit. So, I am actually a Bachelor of Secondary Education student majoring in Mathematics. So, for today's task, I will be sharing to you a video discussion all about the double integral and also the differential equation. So, firstly, we will have a quick overview about the double integration. So, this double integration is actually a mathematical technique used to calculate volume under a surface in three-dimensional space or to find areas also in two dimensions. So, it involves integrating functions of two variables, which is the function of the coordinate x and y over a specific region in the x and y plane. So, this process is done step by step, starting with the integration of one variable while treating the other as fixed, and then integrating the result with respect to the second variable. It's either x or y, no? These double integrals are widely used in physics, engineering, and other fields for solving problems involving the density, mass, center of a mass over a given area. So let's try to give an example for this one. So let us try to evaluate the iterated integral. So for number 1, we will solve the double integral of the function of the square root of y all over x. So ranging from x squared to x with respect to y, and ranging from 1 to 4 with respect to x. So for this solution, no? So we will integrate the function with respect to y first. So we will factor out first the x since it can be treated as a constant, no? So what we have right now is the integral of the y raised to the power of 1/2 ranging from x squared to x with respect to y multiplied to x raised to the power of negative 1/2 with ranging from 1 to 4 with respect to x. So for this one, we will solve this first integration, no? So the integral of this part is y raised to the power of 1/2 is 2/3 y raised to the power of 3/2 evaluated from x squared to x. So the next thing is to substitute or to evaluate the integral, no? So we have now is the 2/3, since 2/3 is a constant, multiplied to the integral of this function with respect to x. So we have the x raised to the power of negative 1/2 multiplied to x raised to the power of 3/2 minus x squared raised to the power of 3/2 with respect to the x ranging from 1 to 4. So let's first solve this expression in the brackets, inside the bracket. So as you can see here that x squared, this one we can apply the rule of exponent, no? We have to the distributive, but for this one we have to multiply the 3/2 to 2, which will result to 3. So let's try to look at it now. So what we have right now is 2/3 multiplied to the integral of x raised to the power of negative 1/2 multiplied to the x raised to the power of 3/2 minus x cubed with respect to x ranging from 1 to 4. Right after this one, we can apply the distributive property in which we will distribute the x raised to the power of negative 1/2 to x raised to the power of 3/2 and x cubed, no? So what we have right now is 2/3 multiplied to the integral of x minus x raised to the power of 5/2 with respect to x ranging from 1 to 4. So we can now apply the integral with respect to x. So what we have right now is 2/3 multiplied to 1/2 x raised to the power of 1/2 since we integrate the variable x, which is 1/2 x squared na, minus to 2/7 x raised to the power of 7/2 from 1 to 4. So all we have to do to evaluate this one is to substitute 4 to this expression minus minus to the expression which we have to substitute the 1, no? So let's try to look at this one. So what we have right now is 2/3 multiplied to this expression, which is 1/2 4 raised to 4 squared minus 2/7 4 raised to the power of 7 halves minus 1/2 1 raised to 1 squared minus 2/7 1 raised to the power of 7 halves. So to simplify this expression, what we have right now is the negative 200/7 minus 3/4 multiplied to 2/3. So let's try to simplify more, no? So 200 over 7 minus 3/4 equals to negative 400 over 14 multiplied to 2/3. So what we have right now is negative 403 over 21. So therefore, the double integral of the function of the square root of y all over x ranges from x squared to x with respect to y and ranges from 1 to 4 with respect to x equals to negative 403 over 21. So let's try to give you another example for this. So another example is that let's evaluate again the iterated integral of this problem, no? So we will have the double integral of the sine of x over y with respect to x ranging from 0 to y squared, and also with respect to y ranging to pi halves to pi, okay? Not 2 pi, but until pi, no? So let's have the solution. So for this one, we were going to apply the u substitution. So what we're going to let here is that u be equal to x over y, no? So let's try to see this one. Let u equals to x over y. So what we have now is the derivative of u, which is equal to 1 over y dx. And what we have right now is dx equals to y du. So for this one also, we also have to adjust the boundary since we apply a u substitution. So it will be like easier now. So we won't have to substitute back what we let earlier, no? So for adjusting the boundaries, when we let x equals to 0, or which is our lower bound of this integral with respect to x, our u is equal to 0 since u equals to x over y equals to 0 over y equals 0. So when we let our x be equal to y squared, which is the upper boundary of our integration with respect to x, so what we have for our u is y. So u equals to x over y equals to y squared over y equals to y. So to continue, no? So from this double integral, no, what we have right now is the integral of y multiplied to the integral of sine u with respect to u ranges from 0 to y with respect to dy ranges from pi over 2 until pi, no? So firstly, we have to integrate our first variable, which is the with respect to u. So what is the integral of sine u, which it is negative cosine of u. So for this one, what we have right now is the integral of y multiplied to negative cos u ranges from 0 to y. This is with respect to dy ranges from pi over 2 until pi. So to evaluate this integrated function with respect to du, we will have to substitute the lower bound minus to the substituted of the lower bound, no? So what we have right now is the integral of y multiplied to negative cosine of y minus of the minus of the cosine of 0, no? So we all know that cosine of 0 is negative 1. Negative cosine of 0 is negative 1. So, with respect to dy, ranging from pi over 2 until pi. So, what we have right now is the integral of y multiplied to the negative cosine of y plus 1 with respect to y ranging from pi over 2 until pi. So, the next step that we will do here is to distribute the y to the negative cosine of y plus y. So, next what we have is the integral of negative y cosine of y plus y with respect to dy ranging from pi over 2 until pi. So, we can apply the addition property of the integration. So, what we have right now is the integral of negative y cosine of y with respect to dy ranging from pi over 2 until pi plus the integral of y with respect to dy ranging from pi over 2 until pi. So, firstly, we will have to solve the first, which is the integral of pi with respect to y. The integral, I'm so sorry, So, the integral of y with respect to y, dy, with respect to y, ranging from pi over 2 until pi. So, for this one, we will have to just integrate our variable y with respect to y, which we will have an answer of y squared halves to be evaluated from pi over 2 until pi. So, we have to substitute the pi over 2 and pi. So, pi squared halves minus pi halves over halves, which is the pi halves, which is raised to the power of 2 or squared. So, what we have right now is pi squared over 2 minus pi squared over 8. Pi squared 8 equals to 3/8 of pi squared. So, the next thing we do is to solve now the integral of negative cosine of y d with respect to y ranging from pi over 2 until pi. So, for this one, it will become the negative of the integral of y cosine of y with respect to y ranging from pi over 2 until pi. So, for this one, we will apply the integration by parts. So, we will gonna have to let u be something of an expression and also the b prime. So, for this one, we were going to let the u be equal to y. So, the derivative of u equals to the derivative of y, which is dy. So, for our b prime, we will have the cosine of y dy. So, by applying the integration, what we have for the v is the sine of y. So, since we have u and b, du, what we have right now is the negative of the y multiplied to sine of y minus the integral of sine of y dy ranging from pi over 2 until pi. So, the integral of sine y with respect to y ranging from pi over 2 to pi is negative cosine of y. So, let's try to look at this now. So, what we have right now is the negative of the y sine of y minus the negative of cosine of y ranging from pi over 2 until pi. So, for this one, we can simply simplify this. So, negative multiply to negative is positive. So, we have now the negative of the sine y plus the cosine of y ranging from pi over 2 until pi. So, we will evaluate our integral with respect to y. So, what we have right now is the negative of pi sine pi, which we all know that the sine pi equals to 0, plus the cosine of pi, which equals to the negative 1, minus the pi over 2 multiplied to sine pi over 2. The sine pi of 2 equals to 1. And adding to the cosine of pi over 2, which is 0. So let's try to look at this one. So what we have right now is the negative of pi multiplied to 0 minus 1 minus the quantity of pi over 2 multiplied to 1 plus 0 equals to 1 multiplied to the quantity of negative 1 minus pi over 2. So we will distribute the negative sign. So what we have right now is 1 plus pi over 2. So the integral of the negative y cosine of y dy ranging from pi over 2 to pi plus the integral of y with respect to y pi over 2 ranging from pi over 2 until pi. So we all know that we already solved this, which equals to 1 plus pi over 2, and we already solved this, which equals to pi 3/8 pi squared. So now what we have right now is 1 plus pi over 2 plus 3/8 pi squared. So our answer equals to 1 plus pi over 2 plus 3/8 pi squared. So therefore, the double integral of the function sine of x over y with respect to x ranging from 0 to y squared and with respect to y ranging to pi over 2 until pi equals to 1 plus pi over 2 plus 3 pi squared over 8. No? So that would be all, and